Okay, sixth grade, we're going to give this a try here, see if we can get some videos out. This is the lesson obviously labeled exponents. I'm just going to go through. I'm going to just advise you kind of go through and take notes as I go through the samples. This isn't my work that I put together. This is Mrs. Van Houten, so I think she just tried to cover as much as she could. So it's not always, doesn't appear like it's always in order, but I think she was trying to give you just exposure to a variety of things. So here we go. So what we're looking at today is exponents. Exponents, that's a big sixth grade deal, introduced in fifth grade. So, and what you see here, these numbers, these are the state standards. These are saying this is what you need to know about exponents in this topic. So for an exponent, basically you just got this thing here. Let's do it, 9 to the power of 4. So all you got to know is this thing is the base, okay? This is called the base. And the other thing is called the exponent, the little to the power of 4. And 9 to the power of 4, it's not 9 times 4, okay? It's not 9 times 4, because that would just be like, you could just show that like this. So why would they have the exponent? So if you start to think of it, just think to yourself, there's something different about this, something different. So it's not that. It's actually 9, it's 4 9s. So you can do the 4 9s. 1, 2, 3, 4, but it's times. And you might say, well, that looks like 4 times 9, right? It looks like 4 times 9, but it's not. So exponents are huge. They make huge, I'm going to say, exponents make huge numbers. Massive numbers. So 9 times 9 times 9. Okay, so watch this. 9 times 9, we can only do 2 at a time, would be 81. Times 9, I can only do this 2 at a time. 81 times 9 would be like 9 times 729 times 9. It's a massive number, massive number. And then 729 times 9, I can't even do that one in my head. I'm going to have to like come over here. 729 times 9. Whoops, that's 81. 9 times 2 is 18. Plus 8 is 26. 9 times 7 is 63. So it's 6,000. So altogether, if I were to do this, underline these two, and what I'm doing here is I'm basically following the order of operations. I just do 2 at a time. Then I do these two guys. Now I just did those two. So I can do an equal sign like this. Okay. So that's 6,561. Okay. That is not even close to 9 times 4, which is like 36. So that's what you want to keep in mind. They make humongous numbers. Humongous. Okay. Let's come down here, and then you have this other thing called exponential form, which means, well, 9 to the power of 4, that's exponential form, okay? 9 to the power of 4. Maybe I made that kind of big. But remember how you have like unit form, expanded form, word form? Well, this is just exponential form. So if you think about that, it makes sense. Another type. Okay, so let's look here. Rewrite this expression in not standard or unit or word, but exponential form. Easy cheesy. How many 7s? 1, 2, 3, 4, 5. It's just 7 to the power of 5. Okay? And again, what's the base? That just means this thing here, the number 7. And the exponent, that's always that little number. That's always the little number at the top, okay? All right, let's come down. So then a lot of times you're going to hear the word squared and cubed. Okay, so for example, you might say that, see, here's squared and here's cubed. So you can think of it this way. When you square a number is just multiplying the 2 parts. Like say, for example, 6 to the power of 2. The reason why they call that is the same as saying 6. Whoops. Oh, darn. I don't think I'm ever going to get good at writing. It's the same thing as saying 6 squared. You might say, well, why do they call that squared? Well, I'll show you. Because basically what they're saying is, this is, by the way, this is 6 times 6, right? So if I make an array, Remember those arrays that we talked about in 3rd grade? Here's an array. Let me do it this way. That means I have to have 6 times 6. Remember, that's going to mean 6 columns. 1, 2, 3, 4, 5, 6. And 6 in each column, so hold on. I think I did that. 1, 2, 3, 4, 5. So now this, I have 6 rows, and then I have 6 in each row right here. Which means that's a square. That's a square. Perfect square. Because all the sides would be the same, right? That's where they come up with 6 squared, okay? Now 6 cubed, so cubed just means cubed. Think about a cube. Think about volume for a cube for a second. Let me see if I can see how I can do a good cube here. Hold on. So it's not a perfect cube because it's kind of rectangular on the sides. Whoops. But hopefully you kind of get the idea here. You got this. What you've got on a cube is, let's say, okay, here's 5 cubed. So for example, let's say the width is 5, the length is 5, and the height is 5. So in a cube, if you want to find out the volume, you've got to multiply. Remember, the length times width times height. So in a perfect cube, that would just be 5 to the power of 3. That would be the same as 5 times 5 times 5. And again, it's cubed because when you're working with cubes, you have to have length, width, and height. Remember how you did volume? The formula for volume is volume equals the length times the width times the height. Well, in a cube like this, in a cube, the length is 5, the width, in this particular cube, you know, it could be like the length is 6, the width is 6, the height is 6. But in this one, you've got, the main thing is that in a cube, they're all the same. Does that make sense? So in a cube, they're all the same. So that's why you're going to see 5 cubed. Okay, so that's pretty cool. And again, look how quickly this number gets. Look at this. It's not like 5 times 3. So don't think of 5 times 3. That's just 15. Look at this. Look at this big boy. This is 5 times 5, which is 25. 25 times 5, which you could do. You could just count by 25s, right? Count on your finger. 25, 50. Whoops, where are my fingers there? 75, 100. Whoops, 105. 125, sorry. So that's a big number. It's way bigger than 15. Okay, so let's look at this. All right. What is the value? So you've seen this word a lot, okay, going all through the different grade levels. Just what's the value? What's something worth of 8 squared? So 8 squared means that the base, okay, which is, well, let's just put it up here. 8 squared means 8 to the power of 2, right? Just means like you got a square, and one side's 8 and the other side's 8. That's why it's 8 times 8 would give you the value of the inside of that square. 8 is raised to the power of 2. Now put it in exponential form, no problem. It says with a base, and the base is just 8, right? That's just the number, because the exponent, we already know what that is. I'll put it in a little different color. It's just that the little 2. Okay, so the exponent, 2, means that the base, 8, is used as a factor. Well, a factor is just like, so here I'll show you. They're complicating that. Watch. 8 squared is the same as 2 8s, right? But not 8 times 2. 8 times 8. So remember, these things, whenever you're multiplying something together, that's just a factor. No big deal. And that's a factor. And our final answer is a product. So when you multiply something like that, you get 64. And I don't know if you remember, but this is an important word too. The answer in that is a product. So the factor times a factor equals the product. Not the sum or the difference, but the product. Okay, so all that means is that the base 8 is used as a factor 2 times. What's the value of 8 squared? Okay, 8 times 8, the value is 64. Ta-da! Okay, so you got that one. You can, again, you can always come back. Let's take a look at this one, see how we're doing for time. Yeah, let's go through order of operations, okay? So basically this order of operations, you've seen this before, and I remember when we were working, we have already worked through this in class, but if you needed to review, it's just PEMDAS. Please, please excuse my dear Aunt Sally. So the tricky thing is, you have parentheses, exponents. I'm going to suggest that you do this. It's actually multiplication or division, whichever comes first, going from the left to the right. So just because that M comes before the D, it could be like division comes first. So if the division is before, like say you're doing something like this, 12 divided by 3 plus 2 times 6, okay? So even though M comes first in that PEMDAS, it's really multiplication or either one of those, whichever comes first. And it's the same thing with addition and subtraction. So it's really addition or subtraction. So whichever comes first, going again from the left to the right, going from left to right. So keep that in mind. Sometimes that tricks people up. They just look at the letters, but you probably should write below there like left and right. That'll kind of keep you straight. Okay, so what do we got? What do we got? What's the value of this expression? All right, so let's just do it over here. I would just copy it just to practice. Parentheses 7 minus 3 to the power of 2 plus 9. First thing you should do is put this PEMDAS up here. And put an arrow so that you remind yourself left to right, left to right. So all you're going to do is one step at a time. Just go one step at a time. So do we have any parentheses? We do. So you do the work inside those first. So it's just one step at a time. 7 minus 3 is 4. 7 minus 3 is 4. But you got this power to 2, so that means whatever's inside there, we got to go to the power of 2. Okay? Now everything else you just copy down. So you only do, the best way to do it is just underline the part you're going to do. Okay? It's like you're going shopping. It's like, oh, do I have any parentheses? Bam, take it off your list. Now you're done shopping for that. All right, what's next? Got an E. Are there any exponents? Yes. So watch how easy this is. I'm just going to underline that exponent. That's all I'm going to do. Now remember, that's not 4 times 2. It is 2 4s, and you're going to multiply them. Okay? So that is 16. Then just copy everything else down. Okay? And don't try to do multiple steps at one time, because you'll just end up getting messed up. It's going to mess you up, so don't do it. All right. Any exponents? No. Any multiplication or division next? Yeah. Okay. Now that's important, because if you were to say I'm going to add 16 plus 9, that'd be a big number. Then multiply by 8, you would get something totally different. So you got to follow the order. So 16 times 8. 16 times 8. Okay. I'm just going to break it up here. That's a 10 and a 6. So 8 times 10 is 80. And 8 times 6 is 48. So all I did was in my head, I just used the distributive property. I just in my head did the distributive property there. So 8 times 10 is 80. 8 times 6, 48. 128. So that's 128 plus 9. Now I can just finish it. Now the best way to do this, by the way, this plus 9, is just kind of add that up, make that a 10. So add 1, then subtract 1 at the end. So just make that a friendly number. So if it was 10, now it's not, but I'm just going to pretend. So I'm going to add 1. 128 plus 10, all I got to do, I got 2 10s in that number. That means I got to have 3. But I won't have 138. I have to subtract 1. Because I added 1 to make it easier, so I have to subtract it. So it's 137. Pretty cool way to do that. Pretty cool way. Okay, let's see. And here's what they did. Okay, same thing. We just had more fun. All right, let's do this one. Let's do this one. And again, I don't think you need to necessarily do all this over here. Let's just work it together, okay? Let's do our PEMDAS. PEMDAS time. Here we go. Please excuse my dear Aunt Sally. Left to right. Left to right. And we got 6 to the power of 2 minus, in parentheses, 5 plus 3 times 8 divided by 4. Oh, that's a big one. So here's the deal. It's not hard. We're going to do one step at a time. Do we have any parentheses? Bam, we got parentheses right there. What is the work inside the parentheses? What's that worth? 5 plus 3? 8. Just copy down. Copy down. What do? We copy. We just keep copy. Okay, and there's a subtraction right there. All right, we're done with parentheses. Any exponents? Any exponents? We got one. We got one right here. Now that is not 6 times 2. That's 2 6s and multiplying them together. 6 times 6. 36 minus 8 times 8 divided by 4. We are all done with exponents. Okay, now what do we got next? What do we got next? Do we have any multiplication or division, whichever comes first? Well, when we go left to right, the first thing we see is 8 times 8. Okay? 8 times 8. That's 64. Copy everything else. That's all we're doing. 36 minus 64 divided by 4. No more multiplication. Take it off the list. What do we got left? Do we have any division? Yes. 64 divided by 4. And I think that's 16. Let's double check. 4, 2, 6. Yeah. So that is 16. Now we just copy down. What do? We copy. We have 6 minus 6. We got 0. 3 tens minus 1 tens. 2 tens. Okay. We got it. We got it. We got it. Did they do a... They didn't give us the final product, but we got it. Okay, so that's good. I'm going to pause. I have a class coming up, and I will come back. I'll come back to this later. Okay, back with you guys, and we're going to keep going. So we just left off this problem here, and we're using our order of operations. Now we're just going to continue with that order of operations, which are kind of fun because you're just doing like a step-by-step. And if you like step-by-step math, by the way, then a lot of this you can do in, like there's accounting that businesses need. If you love doing step-by-step, and finance where businesses need people to come in and help them figure out, what's going on. So here we're going to do number 9, and I'm going to come down here. I don't really have a spot for that, do I? I'm going to do it right here. You may want to get an extra sheet of paper so you can, because you really need to just show work and just give a spot to show if you have to draw stuff out. But I'm going to do my PEMDAS because it's what's the value of this expression, and I'm just going to write the expression 12. Actually, I'm going to put it over here, 12 divided by 4 plus, in parentheses, 2 plus 5 minus, move this guy, move myself down there, minus 6. Okay, so I'm going to do PEMDAS. Here we go. Any work in parentheses? Boom, we got it. Just underline it. 2 plus 5 is 7. Copy everything down. Just one step at a time with this. Oops, divided by 4. That was a mistake. Sorry about that. Let's come back. 4. And this is a plus sign right here. This is a plus. Minus 6. So just cross it off. No parentheses. Okay, I'm done with those. Any exponents? Negative. Any multiplication or division? Whichever comes first, left to right. Well, I don't even have multiplication, but I do have division. So underline that. Let's do it in this color. Underline that. 12 divided by 4 is 3 plus 7 minus 6. Now here, so I've got that done, right? Now here, you might be thinking, oh, I'll do the 7 minus 6 first. That would be a different, that if you did 7 minus 6, because it's addition or subtraction, whichever comes first. So technically what you should be doing is you should be doing this part. Because if you try to do it a different way, let's watch what happens. If you do, we'll come down here. If you got mixed up and said, oh, I'll just do it like that, that would be 3 plus 1, and that is 4. That's not what's going to happen here. Hold on a second. Sorry, I had to kill an ant. Okay, 3 plus 7 is 10. In this case, 10 minus 6. Oh, it does. It comes out the same. So that's not always going to be the case. That's pretty interesting. That's pretty interesting. So so in this case, it does come out the same. But there are definitely going to be times where if you follow the order, it's going to be different. So this time it worked out okay. Okay. So let's move on here. We got that one. Order of operations. We got 4. Just put the solution of 4. All right. And now I'm going to use the same space here. So let me pause it and I'll get. Okay. So here I've got. We're going to do number 10. So I'm going to do my order of operations. And then I'm going to start with 3 times 8 plus 6 to the power of 2, or 6 squared, we learned, okay? Minus 8 divided by 2. Okay. What am I going to do first? Any parentheses? Just cross it off like a shopping list. Nope, no parentheses. Any exponents? Yes. So just underline it like this. Now 6 to the power of 2 means 2 6s multiplied together. So I'm going to suggest just write that down, because the most common mistakes, students start rushing. They do like 6 times 2. So this is 36. Then just copy this down. 3 times 8 plus, and then minus 8 divided by 2. 3 times 8 plus 36 minus 8 divided by 2. Okay? Excuse me. So now I've got any more exponents? Nope, I did that. I have multiplication or division, whichever comes first, left to right. So it just happens I've got multiplication, so I'm going to underline just that one piece. 3 times 8, 24. Plus 36 minus 8 divided by 2. Okay. So now I'm done with my multiplication. Can cross that off. And I've got division. So just going to do that one little step. So now I have, I'm sorry, 8 divided by 2 is 4. And then just copy minus 36 and then 24 plus. Okay. Okay, so now I am just down to addition and subtraction, so underline that. 24 and 36. Now you can see I've got 3 10s and 2 10s. That's 5 10s. So it's going to be 50. But if I look at my ones, I've got 6 1s and 4 1s. That's 10. So I got really 5 10. I have 6 10s altogether. So I've got 60 minus 4 equals 56. Okay. All right, I am going to pause and erase this and move on to the last one here. Okay, here we go. Let's look at this last one here. We've got Mrs. Gluckson, okay, wrote this expression on the board. Marcy says that the value of the expression is 20. Landon says the value is 1. Who is correct? So we're going to have to use order of operations and figure this out. So let's write our little, please excuse my dear Aunt Sally, order of operations. Going from left to right, we'll copy the expression. 19 minus 9 times, in parentheses, 9 plus 7 divided by 2 to the power of 3, or 2 cubed, because that's going to be 2 times 2 times 2. And you might ask, well, what would these kind of things be used for? Well, these, just like you'll see later on in this packet, expressions can be used to describe the behavior of something. So for example, this could be the behavior of like maybe an airplane in flight, and there could be different variables in here. And so what happens is, over time, maybe someone would look at this airplane and they would decide, okay, if it's going at a certain speed and you have the wind is at this certain speed, and then you have a certain temperature, all these things, we notice that the airplanes behave this way. That's where these kind of formulas come from. They're just describing something that's going on, and then we can use them. So they're not just meaningless sentences, just a bunch of numbers, okay? But we want to practice being able to solve and use those because they can be really helpful in designing and predicting the behavior of objects. All right, so here we go. We're going to go to, we got some parentheses, so just underline it. 9 plus 7 is 16. Copy down. Okay, just copy that down. That's 16, okay? I'm all done. Do we have any exponents? Oh, we do. Okay, so we got an exponent. That's 2 cubed. That is 3 2s. 1, 2, 3. And they're all times. Not 2, 4, 6. It looks like it's 2, 4, 6, right? But remember, you're going to do 2 at a time. So 2 times 2 is 4. Times 2, it's 8. So it's always going to be more than, exponents are huge. They make numbers huge. Okay, we talked about that. Whoops, fix that, sorry. So 8, copy across. Okay, done with exponents. Do we have any multiplication? We do. And if we don't do the multiplication, if we were to subtract this first and make a mistake, that would be 19 minus 9 would be 10 times 16, and that's going to be that's different than what it's asking us to do. We come up with a different answer, so we're going to multiply 9 times 16. So you really have 9 times 10 and 9 times 6. So 9 times 10 is 90, right? And 9 times 6 is 54. So we have 144. Okay. Wow, that's kind of cool. That's almost like 12 times 12. So somewhere in there's probably something cool going on. 90 and 54, 144. Yep. Copy across. Got this 19 here, and this divide by 8. Okay. Get these guys out of the way. All right, so let's see. Something looks haywire there. Let me pause for a second. I might have made. Okay, so we're looking here at the last part. We have no multiplication. We've got, got my M. Cross that off. We have division. So 144 divided by 8. So let's come look at that one. Okay, 144. We'll just kind of do it down here. Divided by 8. And there's the last digit's a 4. So that's what I was looking at earlier, and I was wondering. But I think this is divisible by 4 because I think there are rules for divisibility. If we were dividing by 4, then I could look at the last 2 digits. So if we're dividing by 8, so I wonder if I doubled the last 2. But anyways, there's cool ways to find out, like if something is divisible by something. But we know we're going to have a 4 at the end, and we know 8 times 8 is 64. So I'm going to bet this is going to be okay. So 1 times 8. Okay, we'll subtract. So you can borrow, or you can just know 14 minus 8 is 6. And there's where that 4 is going to go in evenly. So it's 18, right? So it's 18. So under here, this is 18. Now I'm going to suggest again that you do this on a separate piece of paper. They don't give us enough room to work here. Okay. And what do we have left? We copy across. So that was a long one. 19 minus 18 is 1. Who's correct? Marcy says it's 20. Landon says it's 1. Landon is correct. Landon is the man. Explain the steps you took to decide who is correct. You could just say, I followed. This is what I would do. I followed the rules for order of operations. My work. And then we're going to draw an arrow to your work. Okay, my work shows that Landon is correct. And so what you're going to do on any math paper, especially on a state test, you're just going to draw an arrow and you're going to put this big arrow, and that says that's my work.